variables. A random variable is a numeric quantity whose value depends on the outcome of a random event. We use a capital letter, like x, to denote a random variable. The values of a random variable are denoted with a lowercase letter, in this case lowercase x. So, for example, p of x equals x. So this is the probability that our random variable x equals some value of the random variable. Two types of random variables. Discrete random variables are often only integer values, but not necessarily, right? They can only take certain values. So number of credit hours, difference in number of credit hours this term versus last term, things that can only be certain values but can't be anything in between. Continuous random variables can take decimal values. They can take any value. We're often interested in the average outcome of a random variable. The average outcome of a random variable is the expected value, also known as the mean, and it is a weighted average of all the possible outcomes. So what you do is you take the outcome and you multiply it by the probability and you add all of those up. Right, so the probability model for the values shown when rolling a die. Right, the probability of rolling a 1 is 1 out of 6, and the probability of rolling a 2 is 1 out of 6, and for a 3, and a 4, and a 5, and a 6. Right, and all of your probabilities should add up to 1. So then we multiply the value times the probability, and so that would be 2 out of 6, and that would be 3 out of 6, and that would be 4 out of 6, and that would be 5 out of 6, and that would be 6 out of 6, and you add all of those up, and that is 15, 18, 21 out of 6, which is 3.5. So the expected value, so this is the expected value for one roll of a die. For the expected value for the sum of 2 dice, you add the expected values, right? So expected value of x plus x is equal to e of x plus e of x, which in this case would be 7. In a game of cards, you win $1 if you draw a heart, $5 if you draw an ace, including the ace of hearts, $10 if you draw the king of spades, and nothing for any other cards you draw. Write the probability model for your winnings and calculate your expected winning. So for a heart, you win $1. For an ace, you win $5, $10 for the king of spades, everything else is a 0. There are 12 out of 52 non-ace hearts, 4 out of 52 aces, 1 out of 52 king of spades, and that gets me 17. Oops. 35 other cards. That should add up to 1. So, x times p of x, right? You have 12 out of 52 times 1. 5 times 4 out of 52 is 20 out of 52. 10 times 1 out of 52 is 10 out of 52. Everything else is a 0. So that gets us 42 out of 52. Which ends up as a decimal being about 0.8. So, when you're calculating the expected value, drawing a chart like this can be very helpful. All right, here's a visual representation of winnings from this game, right? Here's your 35 over 52 cards that give you nothing. 12 over 52 cards that give you $1. 4 out of 52 cards that give you $5. And 1 out of 52 cards that give you $10. We're also interested in the variability in the values of a random variable, right? How spread out those values are. And so the variance, to find the variance, we take each value, we subtract the mean, we square it, and multiply by the probability. All right, so each value, subtract the mean, square it, multiply by the probability, and we add all of those up. And then to find the standard deviation, we take the square root of that. The standard deviation is the square root of the variance. The standard deviation is more useful for interpreting, but the variance is often easier to calculate. So a lot of times we'll be using the variance and then taking the square root at the end. So how much would you expect the winnings to vary from game to game? Right, we said this was a 12 out of 52 probability, this was 4 out of 52, this was 1 out of 52, and this is 35 out of 52. And so this was 12 out of 52, 20 out of 52, 10 out of 52, and 35. Sorry, that last one is 0. Alright, so that last one is going to be 0. So, here. Alright, so we got our expected value of 0.81. What's going on with my iPad today? So then for every number, we take the value and we subtract that expected value. And then we square it. And so we square that, and we square that, and we square that, and we square that. And then we multiply that x minus ex squared by the probability, right? The probability from this column. And we add all of those up, which is not here for some reason. But we add all of these up, and that is 8, 9, 10, 31, 21, 18. And we get a variance of about 3.42, right? So that's our variance, right, which is sigma squared. So then our sigma would be the standard deviation of that, which would be which would be 1.85. So, on average, we expect our winnings to vary by $1.85 per play. A linear transformation of a random variable x is given a, x plus b, where a and b are some fixed numbers. So when we multiply a random variable by a number and when we add a constant, the expected value of a linear transformation works the same way. You multiply the mean by a and you add b. The standard deviation, you multiply by the absolute value of a. You do not add b, right? Adding a constant to all of the values does not change the standard deviation. right? So if I have a distribution that looks like this, and I add 10 to all of the numbers, I'm going to get a distribution that looks like this, right? My standard deviation does not change, but my mean does change. My mean increases by 10 from here to here. So a random variable x has a mean of 10 and a standard deviation of 2. New random variable y is negative 5x plus 10. So our new e of y, right, we just multiply, that's going to be negative 5 times e of x plus 10, right? And this was e of x. So negative 50 plus 10, negative 40. The standard deviation is going to be 5 times the standard deviation of x, right? Absolute value. Adding the 10 does not change the standard deviation. And so that's going to give us a standard deviation of 10. The standard deviation was 2. What happened there? That was a 10. Don't know what happened there. A linear combination of random variables is when we add two random variables together. The same thing with the means, you just add the means together. If x and y are independent, then the standard deviation of the linear combination is given by this, which means add the variances. That's a very complicated looking formula, but it means add the variances, right? Add the variances of the two standard deviations, of the two random variables, I mean. Right, so on average, you take 10 minutes for each statistics homework problem and 15 minutes for each chemistry homework problem. This week, you have 5 statistics and 4 chemistry homework problems assigned. What's the total time you expect to spend on statistics and physics homework for the week? Chemistry. Anyways, so your mean for statistics is 10, and your mean for chemistry problems is 15. So the time you expect the expected value of, we'll call this, statistics plus chemistry. Right, you have 5 statistics problems, and they each take, on average, 10 minutes. And you have 4 chemistry problems, and they each take, on average, 15 minutes. And that's 50, and that's 60, and that's 110 minutes. The standard deviation of the time you take for each statistics problem is 1.5 minutes, and it's 2 minutes for each chemistry problem. What's the standard deviation of the time you expect to spend on statistics and chemistry homework if you have 5 statistics and 4 chemistry homework problems assigned? So your standard deviation, so if your standard deviation for statistics is 1.5 minutes and your standard deviation for chemistry is 2 minutes, then the variance for statistics is going to be 2.25, and the variance for chemistry is 4. So what we should do though, so the variance, right, the standard deviation, when you multiply by a constant, the standard deviation multiplies by that constant. The variance is going to multiply by that constant squared. So what I could do is I could say the standard deviation for 5 statistics problems is going to be 1.5 times 5, which is 7.5. And the standard deviation for 4 chemistry problems is going to be 2 times 4, which is 8. And then find the variances here. So that would be 7.5 squared is 56.25, and 8 squared for chemistry is 64. So then our standard deviation for 5 statistics plus 4 chemistry, we're going to add our 2 variances, and then we're going to take the square root. Which is 10.97. minutes. Or when we found the variances here, then you could multiply them, right? You would multiply this by 5 squared and multiply this by 4 squared. And it's going to get you the same thing. A casino game costs $5 to play. If you draw first a red card, then you get to draw a second card. If the second card is the ace of hearts, you win $500. If not, you don't win anything, i.e. you lose your $500. What is your expected profits or losses from playing this game? Right? So the expected value of your winnings, right, is going to be the probability of winning. So the probability of drawing a red card and then drawing the ace of hearts. Your probability of drawing a red card that is not the ace of hearts is 25 over 52. And then your probability that the next card you draw is the ace of hearts is 1 over 51. And that ends up being a probability of 0.0094. So your expected value of your winnings is 0.0094 times 500. Which is 4.71. But then you would also cost $5 to play. So your expected value of your profits is going to be the expected value of your winnings minus $5, which is going to be $4.71 minus 5, which is negative 29 cents, or a loss of about 30 cents. A fair game is defined as a game that costs as much as its expected payout, i.e. the expected profit is 0. Do you think casino games in Vegas cost more or less than their expected payouts? If games cost less than their expected payouts, it would mean that the casinos would be losing money on average, and they wouldn't be able to pay for all of this. And this is why the house always wins.